Hello students, today we will see the refraction and the laws of refraction and also the refractive index, the formula for the refractive index. Okay, clear children? Now, if I have a glass slab like this, okay, I have a glass slab like this, and I have let a light ray to pass through this glass slab. Okay, so this is a glass slab. I have let an light ray obliquely to pass over here. This is mean by oblique. But if the glass slab is here, but I have let the light to pass like this, there won't be any refraction. The path goes straight away from one medium to another medium. But if it is falling obliquely, it bends. This is the normal. This is along normal. If it flows along normal, then it won't get any deviation irrespective of the density of the medium through which it passes. Clear children? Now if it is falling obliquely on the plane, then it have some refraction either towards or either like this away. Okay, away, either towards or away. Okay, I will draw the glass slab over here. Okay children, now this one condition, this is one condition, this is one condition. Why this path all changes, I have put on video. Why, what causes this refraction. Now this is the introduction. I have put what causes this refraction in a separate video. If you have any doubt in the causing over, you can refer that video and come to the laws of refraction. Okay, now laws of refraction. First law, we have the incident ray. Okay, now it's laws of refraction. Okay, laws of refraction. Okay children, refraction. Clear? First law is thus incident ray, the angle between them, the normal and the ray is incident angle. The angle between the normal and the refracted ray is the refracted angle. Likewise the same over here. So the incident ray, this ray, and this is the refracted ray, and this is the incident ray, this is the refracted ray. Correct? Now the first law states that the incident ray, the refracted ray, and the normal and the sine of the angle of refraction. Okay, this sine of the angle of refraction is constant for a the incident ray. Okay, the incident ray, the refracted ray, and normal to, one second children, be clear, I should be clear, sorry. Incident ray, refracted ray, and the normal to the interface at the point of incidence all lie in the same plane. Okay, this is a plane, horizontal plane. Correct? All lie in the same plane. They won't go back or come front any direction. All lie in the same plane. That's what the first law. Shall I write it over here? The first law states that incident ray, refracted ray, and then normal, and the normal to the interface. Okay, to the interface at the point. Okay, this point, at the point, okay, at the point of incidence, all lie in same plane. Clear children? In same plane. same plane. That's what the first law. Clear, children? Next, it is the second law. Now we are moving into the second law. Okay. So the second law is the important one in the case of refraction. Clear? So the ratio of the sine of the angle of incidence and the sine of the angle of refraction is constant for a given pair of media. What is sine? So I will explain over here. Okay, clear? Now if I have drawn a line over here, this is the refracted angle, and now if I take sine of r, okay, if I take sine of r, what will you write? Opposite by hypotenuse. What is opposite? Let's take it as ABO. So opposite is what? AB, and this is hypotenuse OB, correct? This is what the sine R. Likewise sine I. If you draw a line over here, what will be sine I? I write over here. Sine I will be, I will take this as C. Clear? C O A next to D. Opposite by hypotenuse CO. Now if I take the ratio of this and this, that is sine I, okay, sine I by sine R, they will be constant. Clear? This is what the second law. Sine I by sine R is constant. This constant value gives the refractive index of the medium. Okay, so if I take 2 with respect to 1, this is means that 2 with respect to 1. What is 2 with respect to 1? The speed of light in for definition, I'm saying for your understanding purpose. Okay, this speed of light in the second medium with respect to the first medium. Okay, this is the refractive index of the medium, of the second medium with respect to the first medium. Okay, we are considering this and finding the refractive index of this medium, not the refractive index is constant for if you take quartz or any other things like quartz or any prism with any material or water or quartz or oil, anything if you take, it won't be constant. It depends on the medium with respect to the first, that is the first medium, depends with respect to the first medium, it won't be constant. So if I take this medium to be water with respect to glass, this refractive index will be different. If I take this water with respect to some other medium, outer medium, this refractive index will be different. So the refractive index is constant with respect to the two mediums, not a single medium. That's what we are saying. Okay, now we'll move on to the refractive index. Okay, refractive index, that's what the same thing. We will derive the formula over here itself. See, children. Now, refractive index. Refractive index. The first thing is, I will give you the definition of a medium. The refractive index of a medium for a light of given wavelength may be defined as the ratio of the speed of light in vacuum to the speed or in that medium. Clear? Speed of light in vacuum with respect to the in the medium, the ratio. So refractive index, I will write here. Second, so refractive index, how can you define? Refractive index will be refractive index can be explained as speed of light in vacuum. Okay, speed of light in vacuum by speed of light in medium. speed of light in medium. So this is, if you take consider this medium to be vacuum and this medium to be any medium like water or glass. So the refractive index of glass will be calculated with respect to the vacuum. So another formula is also there. The refractive index of medium for another formula is also there. In terms of wavelength, this is in terms of speed. This is, I will give separate color because we have to remember. This is in terms of speed. Okay, in terms of speed. Now if the refractive index will be calculated in terms of wavelength, okay, we will write here refractive index with in terms of refractive index, okay, refractive index in terms of wavelength, correct? Wavelength, how can you write? That's the formula over here, C by V. C is speed of light in vacuum and V is speed of light in medium. We know that speed can be written as wavelength into nu. I have taught this formula in the structure of atom as well as the atoms lesson in physics and chemistry both, how this formula is derived. So see that. So C can be written as lambda, or that is wavelength into nu, that is this frequency, and wavelength in medium into frequency. Okay, I have written vacuum and medium to the lambda alone. Why should not I write here? Because the frequency won't change with respect to medium. I highlight again, frequency won't change with respect to the medium. You should be clear. Frequency is constant, won't change. Okay, clear? Be clear with that. So only I have written only vacuum and medium for lambda alone. Okay, clear? Now this frequency can be cancelled, correct? So lambda vacuum by lambda medium, this is the formula. Clear, children? Lambda vacuum by lambda medium. Okay, clear? Got the point? Now the relative refractive index of medium 2. Now I have calculated this speed of light with respect to the vacuum. No, this is what we call it as absolute refractive index. If we calculate the refractive index of a medium with respect to vacuum, then it is called absolute refractive index. Clear? Absolute refractive index. If this is the first medium is vacuum, the second medium is water, the first medium is the first medium if you take as water, the second medium to be glass. So if I take like this condition, okay, clear, water, and I have take glass prism over here, then what will be the condition? This is medium 1, this is medium 2, correct, children? So if this is the condition, any other medium except air outside, then it is not absolute refractive index, it is called as relative refractive index. Clear? So what is the difference between absolute refractive index and relative refractive index? You should be clear with that concept. Clear? Now next is, how can we write that formula? M nu 2 with respect to 1 v1 by v2. Simple. Instead of vacuum C, we have to substitute the velocity formula which they have given in the question. Now, the factors on which refractive index of a medium depends. So, I will write that also. It's also an important point. Factors on which refractive index depends. Okay, depends. Okay, children. Now, shall I write that causal factors? So, the first one is nature of the medium. Nature of medium. The second point is nature of the medium and wavelength of light used. Wavelength of light. Clear? Nature of medium, wavelength of light. Try to memorize while listening the class itself. Don't waste time in memorizing everything after that. So these things are all you should be memorizing during the class itself. Lambda of light, nature of medium, and then temperature. The fourth point is nature of the surrounding medium. Clear? Nature of surrounding medium. Okay, children. So that's it. What we have dealt with the refractive index. So clear? So this is what we have seen in today's class. So be clear with this concept. So next we will move on to another concept, that is the refraction through a combination of media. Okay children. Now if you have any doubt, please comment in the comment section and subscribe our channel for more videos.